longer than what we know on Earth, so the Artemis base will experience 2 weeks of continuous sunlight, but then it will be plunged into another 2 weeks of darkness. During that time, the temperature will drop below negative 200 degrees Celsius, and without a source of heat, all of the hardware will freeze solid. That tends to be really bad for electronics, and they typically don't come back to life when the sun rises again. So NASA is going to experiment with radioisotope thermal generators. Basically, you have a radioactive element like plutonium that is actively decaying. That process naturally releases heat, and this heat can be captured to prevent assets on the moon from freezing solid. What kind of assets are we talking about here? Well, NASA has a radical new idea for exploring the moon: rocket drones. They call this new vehicle Moonfall. It's based on the Ingenuity Mars helicopter platform, but instead of propellers, it uses small rocket thrusters to move around. Each drone can fly for 150 seconds in one hop and cover up to 50 kilometers distance. They are going to use these to explore dangerous and hard-to-reach locations like tops of mountains and edges of deep craters. During Phase 1, NASA will also deploy their Viper rover. This is a golf cart-sized vehicle that is already built, tested, and has been waiting for a ride to the moon for years. 2027 will finally be that year. Viper will arrive at the moon on a Blue Origin lander. Once there, it's going to begin mapping the South Pole region for confirmed signs of water ice and other volatile materials like hydrogen, oxygen, and rare earth metals. NASA considers this to be lunar prospecting. Establishing the locations of these resources will be critical when Phase 3 comes around. Viper will be joined on the ground by 2 lunar terrain vehicles, one to be driven by the crew members and one that drives autonomously. Each rover will be able to cover up to 900 kilometers of the lunar surface, and beyond just exploration, they'll be used for work purposes like moving equipment and leveling ground for new construction. Overhead will be a new group of lunar communications and observation satellites. These will allow continuous data streaming from any location on the moon to the surface of the Earth with a 500 megabyte per second throughput. They'll also provide a continuous view of the entire lunar surface from space. Now, this is very important to us, as in you and me, because NASA has mandated that all of these vehicles we just mentioned, the drones, the rovers, the electric cars, they are all going to be equipped with high-quality cameras that will live stream their entire mission back to Earth for everyone in the world to see. That sets us up for Phase 2, the transition into building a moon base. This plays out from 2029 to 2032. It involves 27 launches and 24 landings, and includes the first infrastructure for permanent habitation modules. Over this time, NASA will deliver 6 new rovers, and these go beyond just exploration. NASA is talking about excavation in this phase, machines that can move rock, level ground, dig trenches for power cables and pipelines. We are building the foundation for things to come. One of these new rovers will also be the first pressurized mobile habitat. It's a vehicle being developed by the Japanese Space Agency in partnership with Toyota. The 15,000 kilogram vehicle will essentially become an apartment on wheels. Astronauts inside will be comfortable enough to hang out in short-sleeved t-shirts and will travel at a speed of 3.5 kilometers per hour for days on end. The rover is expected to have a 10-year lifespan and will operate for up to 150 hours in total darkness. Phase 2 will also demand more power than ever before, and that comes in 2 flavors. The first will be solar energy. Solar panels will be mounted on top of long poles to capture as much sunlight as possible, and they'll be connected into large battery systems for long-term energy storage. That is going to be supplemented with nuclear power, and this goes beyond just keeping things warm. NASA will deploy nuclear fission reactors to the moon that generate hundreds of watts of electricity and supply multiple assets simultaneously. By the end of Phase 2, everything will be in place to support people living on the moon for extended durations. Now, Phase 3 is where we actually move in. This covers everything from 2033 onward, and the highlight of Phase 3 will be permanent habitation of the Artemis moon base. NASA projects that they can have a rotating crew of 4 people staying on the moon for 28 days on a single mission. People will be living in multiple connected modules, basically a space station like the ISS or what Gateway was imagined to be, except built on solid ground. The Habitat modules will be powered directly by their own nuclear fission generator and will be supplied with around 8,000 kilograms of food, water, and air every month. Outside of the base, NASA will begin their first in-situ resource utilization. That means harvesting rock and soil from the environment and using it to their advantage. Water can be extracted from ice reserves in the bottom of shadowed craters. The water can be split into oxygen to breathe and hydrogen to use as fuel. NASA is also going to start experimenting with 3D printing, taking dust from the surface and melting it down into a pourable cement that will eventually build the first genuinely permanent structures on the moon. Now, if you're thinking that this sounds like doing the impossible, then you are not crazy. NASA has admitted that what they are trying to achieve is very nearly impossible. But that's kind of the point. We're not doing this because it is easy, but because it's hard. The Chinese are also fully prepared to do hard, nearly impossible things. These are the stakes of the new space race. Good enough is no longer good enough. And NASA knows something now that they've been missing for a long time. Because the real key objective of this whole Artemis plan isn't actually to build a moon base. The real imperative is to inspire the next generation of scientists and engineers, the young people who will accomplish things in their lives that we would genuinely believe to be impossible today. But those kids will never do that if they don't have the motivation to go out and make it happen. It's NASA's job to lead by example, and they haven't been doing that for a very long time. But the future is finally back on track today. If you want to see a vision of what NASA's city on the moon will look like beyond Phase 3 of the Artemis plan, then click the box on the screen right now.